Hey guys, if you're seeing this, it means there's been some sort of technical difficulty and I'm not able to do the demonstration live, so we're resorting to plan B and I'm showing you a pre-recorded video of what I would have demonstrated live. And I apologize, this would have been much cooler in an interactive format. But I know that this Chicago Blender user group meeting is at RoboModo, and so I wanted to aim this demonstration at the real-time rendering computer graphics genre. And so I know that PBR is kind of the buzzword right now, which stands for physically based rendering. And it involves concepts that have actually been around for a while. They're just finally being incorporated into games and real-time renderers. And so the scene that you're seeing right now is my exploration using Blender's viewport. And so when I use the term PBR, I'm using it very loosely because nothing is actually physically accurate in this scene. Rather, everything is approximations based on physically accurate ideas. Like Fresnel reflections, for example. I'll plug that element up by itself. Up here, the reflections are blurry as the surface faces us most directly, and the reflections clear as we reach the edge. And so that's a big one when it comes to PBR rendering. We've also got some real-time screen space ambient occlusion. So that's a pretty cool addition from the latest release of Blender. And we also have real-time lighting and shadows. So when we combine all those elements together, we're able to get this fairly realistic result just using Blender and OpenGL in the viewport. So as far as demonstration goes, I'm not going to have enough time to actually show the entire creation process. I do want to show you how to establish some believable lighting, as well as approximate these Fresnel reflections. So I'm going to open up another fresh scene file here, where we have no lighting, no materials, and we're ready to begin adding our lamps. So I'm going to add a spotlight, lamp spot. As we move that into the scene, you can see the icon here, but it's not actually affecting our scene at all. And in order to see those effects over here in my In panel, underneath the shading menu, by default it's set to multi-texture, but if we switch that over to GLSL and change our viewport shading mode to material, now we start to see the effects of our light. And the spotlight specifically is the only lamp that casts real-time shadows. So unfortunately, at this time, we don't have any area lights or point lights to cast shadows. But in my experience, the spotlight works fine for this purpose. And so next, just kind of going with a typical 3-point lighting, I'm going to add a point light. Again, noting that this doesn't cast reflection, so this is just sort of an accent light. And I'm going to kind of push it off to the back left corner. And let's change the color to a pretty saturated red. Yeah, something like that. And we'll change the fall off distance to, let's say, 1. Energy up to 2. Yeah, I think that's good. And then last, I'm going to add a hemisphere lamp, which is like a directional light. So it represents sunlight to a degree. We also have a sun lamp, but the differences between the two are very slim. So I want to use this as kind of ambient fill light. And it's way too powerful, also a wrong color. I'm going to switch it to a blue to kind of represent like a sky dome. And we'll take the energy down to, let's say 0.1, maybe 0.2. Yeah, that's good. And being a directional light, the location doesn't actually matter. It's just the direction that it's pointed. And now for these shadows, you'll notice the edge is extremely pixelated, pretty ugly. So in order to soften those up, I'm going to select our spotlight object. And for whatever reason, we have additional shadow settings once we switch to the Blender game engine. And now in our spotlight object data properties towards the bottom, in the shadow panel, I'm going to switch the buffer type from simple to variance. And while variance softens our shadow's edge, the shadow overall becomes much lighter and kind of weird looking. So we can fix this if we come over to the clipping start value. And as I drag that value up, you'll see inside the cone of our lamp, the clipping plane begins to approach our object. And I basically want to stop that when the shadow stops darkening. So here it's light. As I hold shift, it eventually goes dark to a certain point and then stops. So I'm just going to leave it right there. And now if I switch back and forth to simple, the shadow stays the same color. It just softens the shadow. So that's what I want. And now to actually control how soft the shadow is, we can do that with this size value under the quality section. So the lower we make the value, the softer the edge becomes. Let's go to 256. That looks pretty good. How about 128? Yeah, I like 256 best. Very cool. And at this point, we have some fairly decent lighting as far as lamps go. We do have the ability to turn on ambient occlusion, like I mentioned earlier. That is also in the in-panel shading section at the bottom, ambient occlusion. I believe these are just the default values, except the strength, I know I bumped up from 1 to 1.5. And so with ambient occlusion, again, it's not physically accurate in any way, but it does really help to establish that that object is on top of this square pedestal, thanks to these contact shadows. And now we can call the lighting done and move on to the reflections. Over here in the display section, we can enable only render to get rid of all of our viewport icons and enjoy the pure viewport render. Now, when it comes to PBR and really shading in general, whether you're using a traditional or real-time renderer, I find that reflections are absolutely crucial for realism. And on top of that, Fresnel reflections. If you've watched any of my shader training material before, you know that I am a Fresnel evangelist. And so that's what I'm going to show you now, how to approximate that inside the Blender viewport with a Blender render material. So first, let's select the object I want to focus on and maybe disable only render. Here I have the orb object selected. Go over to the material panel, click new. And this one I'm going to call reflection underscore sharp. And unlike an actual PBR engine where you can plug in an HDRI image, as of now we cannot do this with Blender, but we can approximate it pretty well. And that's with a texture. Here in the texture panel, click new. I'm also going to call this reflection sharp. And now to source an image, while we can't use an HDR or environment image for the actual world and have it affect our object, I can use that same type of environment map that's equirectangularly mapped as a reflection texture. So let me go find my image. And it's going to be this corporate interior image right here. So we'll click on that. You can see that it's been applied in the viewport, but it is static based on the UVs of my model. So we'll scroll down in the texture panel to the mapping section. And instead of UV coordinates, let's select reflection. And now it dynamically reacts to our surface as if it's reflecting a world. So that's a very convenient alternative to using an actual world texture. And we have it currently plugged into the color of our material, which I can intensify from 0.8 all the way up to 1. And if it's still not strong enough, we can use the emit value here. If we take that up to 1, we've got full reflections based on the values of the texture, and we can go above 1 if we wanted to. But kind of the problem with the emission is it bypasses any shading that we have from our lights. So I use that only if I need it and just leave the emission off until I need to bump it up. And so here we have our sharp reflections. Now for Fresnel, I want to have a blurry version of this same material. So I'm going to create a new material. Let's go select that reflection sharp and then duplicate it by clicking on this 2. And I'm going to call this blurry. And go back to the texture panel and swap out our sharp texture. Although actually before I swap it out, I also need to duplicate it. Same way I just did the material. And now swap out the texture where I've created blurry versions, 2 different ones, kind of a mid-range blur and then an extremely blurry version. So I'm going to go with the extreme blurry and make sure that my mapping is correct. It's not, it should be set to reflection. And then I suppose I can get rid of the reflection sharp texture because that's a part of my other material. And make sure it's affecting only the color, which it is. And to see this material, I essentially need to move it to the top of this material list. So let's select reflection sharp and just swap it out for the blurry version. And now in the viewport, we can see what that looks like. And now that we have both individual reflection components, we're ready to mix them using the node editor. Now, if you're familiar at all with Blender in recent years, you're probably familiar with the Cycles engine, which takes great advantage of the node editor and how to build materials in a nodal system. But you may not know that we can also use the node editor for Blender render materials, but it is quite different. I think a much less intuitive implementation. And so to explain how it's different, I'm going to compare it to Cycles, where each shader component is broken down into a BSDF node, and they can be combined and layered entirely in the node editor. But here with Blender Internal, it doesn't use individual material nodes, but rather individual materials themselves. So for example, if I click this little button here, which converts it to a node material, you'll see that our output goes black. And if we look in the node editor, we're left with a material node that expects a full material here. See, reflection sharp, rather than say a reflection node. So I'm sorry if that's convoluted. All that to say, I recommend that you think of this as each material slot is a material component. And so I need to add a third slot to plug in our sharp version of the material, and then undo the blurry reflection as a node material, so it goes back to the way it was before. And now in this top slot, I'm going to clear the material out, create a new one, and call this combo, because this will be the only nodal material that combines each individual material component below it. Okay, I hope that makes sense. Now up to this combo material, enable node materials. And now it makes sense for us to plug in one of our reflection components. So here's the blurry version. I can duplicate this and swap in the sharp version. And now I want to combine these two using the Fresnel as a mixing factor. So Shift A, we can mix with a color mix RGB. And we'll just leave it right there for now, because it will be dependent on our Fresnel, which is accomplished using an input geometry node with a vector normal node. Take the normal vector coordinates into the vector input socket. And now if we plug the dot output socket into our material output, you can see the normal effect in the viewport. I always like to add a converter color ramp to customize the fall off. I'm going to switch it to ease, and then we can drag the black up, drag the white down. And this is your standard Fresnel mixing factor. However, I want to reverse so that the white is along the edge and the black is in the middle. Something like that. So I can plug in our sharp reflection component in place of the white color, and then our blurry in place of the dark color. So sharp goes in the bottom socket and blurry goes in the upper socket. Now let's see what the mixture looks like. I'm forgetting something. Oh, I got to actually plug in our color ramp as the factor for that mixture. And now for the majority of our surface as it's facing us, we have blurry reflections, but right along the edge, they sharpen up. And I can adjust this a little bit more. Maybe something like that. And that is one half of the Fresnel equation. The other half is reflection intensity, which is also controlled by the same color ramp. And so for this, I'm going to add essentially the diffuse material element by adding a new material slot, clicking new material. I'll call this diffuse. And I can change the color to, let's say, blue, maybe a darker blue. And going back to our combination material, duplicate the material node, and let's go grab that diffuse element. And go ahead and turn off specular for that, so that it really is just diffuse color. And we need to mix it with the reflection. Duplicate the mix node, reflections go on the bottom, diffuse on the top socket. And now we've got the beginnings of like a painted orb, or maybe a plastic orb, your standard diffuse plus reflections. And for the mix operation, I like add personally. And this is where we can adjust the factor and now plug the same color ramp to govern this addition of the reflection. And yeah, so along our edges, we get the most intense clear reflection. And the majority of our surface, as it faces us more directly, has the blurrier, less intense reflection. And so I actually want my reflections to be a little stronger. So this is where I would start to adjust the emission value of the individual material component. So not adjusting it on our combo material, but in each reflection. And specifically, I want to adjust the sharp reflections first. Let's bump that up to 1. There we go. Maybe 0.5. And then for our blurry reflections, how about like 0.1, 0.2 maybe? There we go. That's a good start, at least, to a physically accurate, inspired material. How about we bump that up to like 0.3? Good grief, 0.4? Yeah, I don't want the emission to be that much. Let's go back to 0.2, and instead, in the combo, adjust our color ramp so that the black, instead of full black, as we start to take that up, we'll see our reflections strengthen in the middle. And they'll also clarify because we're getting closer to the sharp reflections. So there we go. That's an example of setting up PBR-like reflections for the viewport, which if you know how to do that, you're pretty much winning the PBR battle. It's just a matter of plugging in normal maps, color maps, and reflectivity maps for the cherry on top. And then you'll get to something like the previous scene I had opened. Man, this stuff is fun. I could play with this all day. I'm sorry that I'm not able to answer any questions right now, but I appreciate you watching. Hope you learned something, and have a great rest of your Friday.